Okay, this problem here, what volume of water vapor could be generated at STP by combustion of 250 grams of pentane? Okay, so we're going to use PV equals nRT here. That will be to get the volume of water vapor, but in order to do that we're going to need the number of moles of water vapor. Now to get that we're going to have to do a little bit of stoichiometry. And I like to use this little flowchart here. So what we're going to be doing is starting out with 250 grams of pentane. That'll go here. We're going to find moles of pentane, and then what we're going to do is we're going to find moles of water vapor. And that's going to be from over here. Okay, so let's see how we do that. We'll start out with 250 grams of C5H12. We know grams of C5H12 will go on the bottom. And that's to cancel with these grams. And we know there's a relationship here between moles of C5H12 and grams of C5H12. So we know we have 1 mole, and that's equal to the molecular weight of C5H12. And next we know that the moles of C5H12 will go on the bottom to cancel those. And what we need here is moles of H2O. And the relationship here we get from looking at the reaction, we can see it's 1 mole, that's C5H12, it's 1 mole of C5H12, and that's going to give 6 moles of H2O. So there's your relationship here. Now when we do that, it's going to come out to a certain value. It's going to give us moles of H2O. Alright, so that's how we're going to get the moles from there. Now we can do our PV equals nRT, and you know that we always like to write out our values. And the R values always I like to start with 0.08206 liters, atmospheres, moles, and kelvins. And this can be written as, and we know that the moles and kelvins are on the bottom, so we need negative ones here. Alright, so it says STP. STP we know is standard temperature and pressure, which is going to be 1 atmosphere and 273 Kelvin. That's always what STP is. So at pressure, 1 atmosphere. No significant figures needed. This is going to be an exact number. You can see it matches the units in R, so we're good there. Volume, that's what we're looking for. N, we'll get that from up here. That's the value we just figured out. And the temperature, 273 K. Alright, so now we know that PV equals nRT, so V equals nRT over P. N, that's what we get from here. It's a certain number of moles. R, 0.08206 liters, atmospheres, moles, and kelvins. Temperature, 273 kelvins. Pressure, 1 atmosphere. Alright, so that's going to give us our volume, and the volume in this case will have 2 significant figures because the 250 grams up here only has 2 significant figures. Remember that if it's a 0 at the end here, that means that that 0 is not significant because there's no decimal point here in the number. So only the 2 and the 5 is significant, leaving us with only 2 significant figures here and a volume that will be in liters. Now this will give us liters of H2O vapor to solve our problem.